Hi, so thanks for joining us today. I'm Emily Newberry, a librarian at the Thompson Library. And today we have, we've been doing this sort of noon lunch webinars for the last couple of years. And today we have Sara Samuel, who's an informationist from the Taubman Health Sciences Library. So she's joining us today to talk a little bit about data management plans. And, as we all know, as we're doing our research, there's more and more requirements for how we have to report our data, store our data, that sort of thing. So Sara is going to share a presentation with us, sort of getting us introduced to it and, the concept and kind of different ways that you can go about doing it. So I'm going to turn it over to Sara. Thank you for joining us and go ahead.
Awesome. Thanks so much, Emily. Welcome, everyone. Thanks for having me. So yes, as Emily said, I'm Sara Samuel. I use she, her pronouns, informationist from the Taubman Health Sciences Library. And one part of what I do is just helping researchers with like managing and sharing data. And so I was going to be talking a little bit about managing data in the first part of my presentation. And then the second part will be about writing a data management plan. And just if you guys want to follow along with the slides and have access to all the links and stuff, that is a link in the chat that I just put in there that you can access those. So, I just want to sort of start out by kind of framing with some framing here, right? So as a researcher, you do a lot of different things when you're doing research, right? So you're writing grants, you're designing experiments, surveys, you're speaking in public, designing posters, you're communicating in various ways online, you have technical knowledge. There's just a lot that you do, right? And researchers can engage in all these really more specific activities with varying levels of expertise, right? Like I'm sure you all know some that are like really good at public speaking, some that are excellent at writing grants. Other people might not be quite as good, and some of those, like designing posters or whatever. But like the idea behind this is that, you can engage in these activities with varying levels of sort of expertise and skill. And the same is actually true for data management, right? Everyone who does research engages in data management in some way. It really is this inherent part of doing research, and it really can be done well or not, just kind of sort of depending on your level of skill and your amount of practice that you've had with it, right? But you can choose and learn to manage your data well. It does take time and resources, though, and I want to acknowledge that there is a lack of incentives. So you won't necessarily win grants for writing, good data management plan or having a good storage set up for your data. But we at the library and most funders and publishers these days think that it's worth it to put that a little bit of effort into that data management and that planning piece. So, like I mentioned, I'm going to spend some time today talking first about some sort of recommended practices for managing and organizing your data well. And then I'm going to follow it up with the second part where I talk about more specifically how to write a data management plan, which is just kind of one piece of what you can do to help manage your data well. And at any point, if you have questions, feel free to toss those into the chat. I'm happy to address those. And there's not too many of us here, so you could also raise your hand and I'll try to keep an eye out for that as well. All right, so first part where I'm going to talk about here about managing and organizing your data. I wanted to get us started actually with a poll, so let me pull that up. Let's see, this poll number one, launch. Okay, so you should see that now. So the question is, have you ever lost some data or notes because of a lack of organization? So you can choose yes, no, or maybe. So just take a look at those poll options there. Think about maybe something that's happened to you in the past. I know that when I was in college, I was writing this an essay. It was actually for computer science, I think, and I had grabbed a bunch of books out of the library, and I distinctly remember that I had taken all these notes out of this one particular book, and then when I went to go and actually write my paper, I could not find those notes. It was like I could see them on the page in a particular notebook, but I could not find them anywhere. It was just like I had no idea where I had actually written down those notes. It was so frustrating. So it looks like let's go ahead and share these results. It looks like I'm not the only one to have experienced something like that. So it looks like we've got about 4 people who have said yes, that they've definitely lost something like data or notes. A few people said maybe, and then we had one person that say no. Well, congratulations to that no person. You are so lucky. Congratulations. Maybe you don't even need to be here. I don't know. No, I'm kidding. Thanks for being here, everyone. All right. Thanks for taking that poll. So yeah, it seems like that's a kind of a common occurrence, right? If that's happened, so if this sort of thing has happened to you, obviously you're not alone. But second, I really am hoping that today's webinar can just help all of us come away with maybe some ideas or tools that can help prevent this sort of thing from happening in the future. So to help us understand this in a more visual way, this slide just shows an example of like how much and how quickly data could be generated, right? So when you're thinking about kind of a particular project that you're working on, there's lots of files that can be generated from just one project and possibly like multiple people. And without good data management in place, it could just be really easy to misplace or misunderstand what a file is. So on this slide, you can see we've got this is just an example, like if you're working with a rat heart and you maybe get hundreds of slices from that particular like physical piece of material, you end up with hundreds of slides from those slices. You end up with like thousands of image files from the experiments that you're doing, and you could end up with even hundreds of like really huge images where you're sort of combining information together. And you could have multiple people working on this project, right? So with the number of people, the amount of and type of files, there's just so many different ways that data could get misplaced or misunderstood. So just a little bit of a visual example here. So good data management is just something that's good for you, the researcher, right? So as we saw in the poll, some of us have had experiences with losing data, maybe losing a storage device or having a file become obsolete, or maybe you've had a hard time understanding what you meant when you like reread some notes or you look at data that was collected a long time ago. Good data management can help with this, right? So overall, good data management just leads to better organization of your workflows, which can also lead to a more efficient research process overall. So good data management can help you more efficiently find your files, can track your methods for reproducibility, can help you implement better version control of your data, and just overall increase that quality control, right? So it can also help you with avoiding data loss, help you better document your data for your own reuse. And overall, kind of in the end, ultimately, it can just help you gain credibility and recognition when you then share your data, because that good data management can just help make sharing data a lot easier and a little bit smoother in the end. But also, data management is important because it supports some of the core scientific values like transparency and reproducibility, right? Also, since data from one project can contribute to another project if it's managed and then ultimately shared well, it can help to really further scientific progress and innovation. Data is a valuable asset, right? It takes time and it's expensive to collect data, so it's important to take good care of it. Well-managed data can really improve the quality, accuracy, and integrity of your research, maximizes the effective use of the data if it's managed well. That way you're actually, you're not kind of wasting time or resources trying to find it in the future. It ensures it can help to ensure appropriate use of data and information, can strengthen the reliability of the research, and can ensure sustainability and accessibility, allowing others to ultimately, again, reproduce your findings in the end. All right. So there's really just kind of three things that I think are kind of the keys to success for ensuring that your data stays organized and managed well. No matter how you decide to organize your data and files, you should really make it a priority to maintain good documentation about your organization strategy. So you can do this by creating README files with information about where your data files are located and what your organization strategy is. Also, you can create and maintain a data management plan for each project or the lab generally, and I'll talk a little bit more about data management plans in a little bit. Creating and maintaining that good documentation is just one of those keys to ensuring that you stay organized over the long run. That said, creating good documentation won't really be enough on its own. You really need to make sure that you're communicating thoroughly because most likely you're doing research with more than just yourself. You're working with a team, you're working with graduate students, undergraduate students, staff researchers, you have, project managers that you're working with. Lots of people help with doing research, right? So creating that good documentation is usually not enough on its own. You just want to make sure that no matter what your organizational strategy or tactics you use, whatever your choices are, they have to be communicated with the people that are involved in order for it to actually be used and be effective. So after you're establishing your method of organization, you could do things like provide a training session, either in person or on Zoom, by creating a video, setting up a Canvas module. Provide some way to teach your method of organizing and where you're storing things to everyone that needs to know. Additionally, make sure that your documentation is findable and usable. So people will not remember the details, right? Like even if you hold a training session, they might remember for a little while, but really it's like when they're kind of in the thick of things, that's when they're going to need to know what to do, where to put things, how to name their files. So you want to make sure that you're sharing them in a variety of places, so that way they can reference it whenever they need it and kind of at the moment of need. It's also good to use a variety of communication mediums so that when people reach that kind of point of need, they can really search to find what they need to know where they're working the most. So you could do things like, share the video of the training or link to the documentation via email, put it in a Slack or kind of whatever communication method you tend to use in your research group. Make a note in a physical lab manual if that is something that exists in your laboratory or your research areas. Share it where people will actually look for it, right? And then don't just communicate about it once, right? I mean, providing a training is great, but you kind of have to regularly check in to see if people have questions, remind them about how the files should be organized and what file naming conventions they should be using, and where to find that documentation on a regular basis. And then finally, another key to success is that if you can, assign one person to be responsible for ensuring that all of your organizational strategies are being adhered to, and that some minimum level of documentation is being recorded as needed, right? That version controls are being followed, that data is being backed up. That could be you, right? But it could be someone else in your laboratory. And it's not like this person has to be like wholly responsible for creating all the organization strategies. It's really the idea behind it is that ultimately, everyone is essentially in charge of making sure that their data is documented and organized. But if there isn't someone kind of just always checking in, kind of taking the lead, the assumption is, oh, someone else is taking care of that, right? So again, while everyone needs to be involved in kind of managing that data well, it's just really helpful to have one point person ultimately in charge of checking in. So does that all make sense? Do you guys have any questions about any of that? Okay. Again, any questions come up, feel free to put those in the chat or raise your hand. Okay, so now that we understand the need for documentation and communication, you actually have to have something to document and share, right? So here's a brief list of tactics or concrete things that you can do to organize your data. And these are kind of roughly in an order that you would want to do them. Like if you're starting a new project, this is kind of the order that you want to go about thinking about your data, right? And how you want to organize it. So the first thing you want to do is identify storage solutions. Then you want to make sure you establish directory and folder structures. You want to develop a file naming convention or conventions. And then you want to decide on file formats. And then we're going to go into detail about each of these next. So the first thing you'll need is a place to put all of your data, right? You don't want to go through the process of setting up folders and files just to have to like shift things around later. So really you want to identify your storage solutions and settle on where things will be stored first. Depending on the complexity of your data or your project, you might actually have multiple locations where you're storing your data and files related to your project. And if you don't already have some established storage location or locations for your data, I encourage you to check out the ITS Data Storage Finder to learn more about your various storage options on campus. I believe U of M Flint folks have access to these options, but if someone knows better, please correct me. I tried to do some searching and I was like, I don't see any other information about like storage, like research storage on the Flint U of M Flint's website. So I think you guys have access to this. But again, correct me if I'm wrong.
I believe so, but yeah,
Okay.
if I find out otherwise, I'll let you guys know. But I believe
Okay,
we have
awesome.
three campuses.
Great. Thanks, Emily. And then finally, once you kind of have your storage locations set up, then you want to then make sure that you have appropriate access and permissions set up for each of those storage locations. But again, whatever you decide, make sure you're documenting your decisions, right? So going back to those keys to success, you want to document and communicate where things should be stored. The second thing you'll want to do, let's say cluster storage as one solution. Okay, yes, thank you for sharing that in the chat. Yeah, so another thing you want to do is establish your directory or folder structures. So there's a number of ways to go about doing this, and a lot of it really has to be based on kind of you or your research team's workflows and kind of what makes sense for you and your usual way of finding your data, things like that. But some options include you can organize directories hierarchically, group files of similar information together in a single directory. So like you'd have images in one file, spreadsheets in another. You could name directories after aspects of the project rather than individual researchers. And the reason you might want to consider doing this is that it's kind of important for longevity because you might have researchers that kind of come and go throughout the years. And if they're using their initials or their names in the folders or file names, that could become meaningless over time. That said, there might be some situations where it really does make sense that people kind of have their own folders for their work. So again, kind of these suggestions are kind of just recommended practices, but obviously, take into consideration like kind of your particular situation and your particular team and your needs. Another thing you could do is choose to separate kind of that ongoing work and completed work. And then in general, once you have a directory structure and you follow it, you want to make sure that you follow it consistently and you audit it periodically just to make sure that files are being correctly organized into the appropriate folders. And then you can always make adjustments as needed to your organization as your project goes on. And then again, as before, document it, right? Make sure you're documenting and communicating how folders should be organized. So here are a couple of examples of directory or folder structures. So in the one on the left, you can see that they have like a main project folder, and then within that folder are two subfolders. One is for the data that the project generates, and the other is for the documentation about the project and more of the metadata. So within each of those folders is additional information. So the data folder includes databases, images, sound, and text data with additional subfolders as needed. And then the documentation folder includes the consent forms, the information sheets, and the methodology information. In the two examples on the right, you can see two types of organizing. So one is by file type with the data folder that includes the processed and raw data. And then they also have a folder for the results in the form of like figures or models. The other option is to organize by analysis. So then each figure has its own associated data and image included in a separate folder. But you'll notice that in both of these two examples on the right, they do include a README file. So that's something to keep in mind. So then the third thing you want to do is to establish your file naming conventions. And ideally you would do this kind of before starting a project. Obviously, you might need to like wait and sort of see exactly kind of what files you're producing, but what is a file naming convention? So really it's a way to name your digital files in a systematic and understandable way. So you want file names that can embody the content of the file in some way. And of course, there's going to be limitations for how long you want to make a file name, but as much as possible, you want that name to embody the major parameters of the data in the file. If it's raw data, you could include the word raw in the file name, or if it's clinical information from like the first visit of a patient who's participating in a trial, you might include the phrase like first visit in the file name. It's best to use non-cryptic, intuitive names wherever possible. So kind of considering that if you're going to be using like acronyms or something like that, just make sure that you explain what those are or any like shorthand that you might be using, because you might not remember that when you're looking at files at a later date, right? File names should also be extensible. So if you can plan ahead as to about how many files there will be, you can choose to use a number of digits in any file name element for which you're cycling through numbers so that they will sort properly. So if you're going to have about like 50 files, you want to make sure that you use 2 digits. If you're going to have over 100 files, make sure you start out using 3 digits, things like that. File names should be unique where possible and practical. It's best to really avoid having files with the same name, even if they're in different folders, because if a file accidentally gets moved around and you don't have a unique name, you just run the risk of overwriting data or like losing a file. Also, it's best to avoid using any special characters when constructing file names. So you might be creating a file on a platform that might allow for special characters, but then if you move the files onto another platform or if you go to share your data, again, you want to try to avoid those special characters. It can really cause issues. So it's best to use like kind of stick with numbers, letters, and like underscores or dashes. Those are kind of best practices there. And then finally, if you use consistent documentable names, it'll just be easier to parse what's in each file and easier for others to decipher in the long run. Something else to consider is that you might need to include versioning in your file name. I know some like storage platforms include versioning. So like I think like Box kind of has a way of sort of tracking versions of files without having to necessarily include that. But you also might need to consider having multiple file naming conventions, again, for maybe sort of separate aspects of your project, or if you have kind of a lot of files, and you can sort of divide it in a way that makes sense and have a file name convention for each of those sort of separate sections. And then again, as always, just make sure you are documenting what your file naming convention is, and then making sure that you're communicating it out to your team. So before we look at some examples of file naming conventions, I just wanted to talk about formatting dates specifically, because there is an internationally recognized standard for date and time format that's very helpful for using in file naming conventions. So the ISO 8601 indicates that you should write the date with the 4-digit year first, followed by the 2-digit month, and then the 2-digit day. And then you can use hyphens or omit them, whichever you prefer. One nice thing about this standard is that once it's applied, it does provide a really useful way to be able to sort your files by date accurately if you put the date first in your file name. So this standard does include a way to format for time as well, so you can take a look at the included link to learn more, and I'll stick that in the chat as well. Great standard, highly encourage using it. All right, so here are a couple examples of file naming conventions. So the first one over on the left, you can see has a variety of information, including an abbreviation for the experiment name, experiment number, sample number, an abbreviation for the stain used, just a very simple version of coordinates, and an indication of like the data stage. In this case, it's raw in the example. The second example on the left is a little bit simpler with just the project name at the beginning, the date in a standardized format according to ISO 8601, a brief description of the file content, and then the version. In both of these examples, abbreviations are used, so you'd want to make sure to document those. So if you know generally ahead of time the various experiments for the project names, you can document acceptable abbreviations so that everyone's on the same page. Or you can just update your documentation as necessary to accommodate new abbreviations as needed. Also, I just wanted to point out that both of these examples use underscores in between the different sections of the file name. So then the last thing you can do is to decide on what file formats you'll be saving the data in if you have a choice, right? So the recommended practice is to try to choose file formats that are not proprietary, they're unencrypted, uncompressed, in common usage by the research community, adherent to an open documented standard, interoperable among diverse platforms and applications, royalty-free when without any intellectual property restrictions, and then developed and maintained by an established open standards organization. Obviously, though, something to be aware of is that, if you're using a particular instrument or device or some kind to generate data, you might be limited on your file format options kind of based on those device settings. And again, once you've made your decisions, just make sure you're documenting and communicating them to your team and other people you're working with. All right, so here you can see just a list of some of the recommended file formats, depending on what type of data you're working with. The Library of Congress has a great resource for this called the Recommended Formats Statement, which you can check out. Put that link into the chat. But again, I'm not going to go through all of these in detail, so definitely take a look at this if you want to see some of those recommended formats. All right, and because I have I've mentioned README a couple times now, README files. So I wanted to just cover that briefly before we go on to talk about data management plans. But README files are documents that tell others what they need to know in order to use your data. So that'll include things like where to find it, how to access it, what it can be used for, any known problems, inconsistencies, limitations to the data, the collection methods that were used, the units of measure, what variable names are, and so on. And so there is this resource that I linked to. It's a PDF called Quick and Dirty Data Management, 5 things you need to be doing now. That might be a useful resource. So I'll stick that into the chat as well. So here you can see just some of the information that you'd want to see in a README file. And here are some recommended practices for README files. So ideally, it would be great, if you can create one README file for each like data file or data set, kind of what makes sense for your project. Name the README so that it's easily associated with the data files that it describes. Write your README document as a plain text file, so that uses that .txt format on the end. And if you're going to be creating multiple README files, it's useful to create them identically. So using a template, and you can either create your own or you can find one. If you just Google templates, there's a lot of options out there. And there is a link there that has some information from actually Cornell has some great resources about writing READMEs. And then of course, you might have some conventions for your particular discipline that you'll want to make sure to follow with your README files. So this next slide has a lot of text. You don't have to read it all. And I know it's kind of small, but this is just an example README file that you can see that they've included the date. They have the title of their data set. They have the names of the data set creators or the authors. The contact information for the person, like if people have questions about the data, some fun information about their funding source. They have some key points about their data, kind of what it's actually covering, their research overview to help people understand, okay, what exactly is this data set and what can it be used for? Provide some information about the methodology, includes some information about the files that are included in the data set. Any related publications is also listed there. And then there's actually a citation down at the bottom of that file. So a recommended citation if people are using the data set. So this is all useful information that could be included in a README file. And a README file that's associated with data that's shared might look a little different than a README file that you kind of keep locally with your data files that sort of talk more about the organization that you're using to help people find data when you're kind of working on it actively. Okay, so I went through a lot, but let's get practical for a minute, right? Because you're not going to be able to change all of your current workflows and practices overnight to just magically get organized. So you really need some practical steps to get started, right? No matter what you end up implementing, you want to make sure that you're kind of fitting it with your situation and your overall goals for your lab or your work or your data, right? So think about what actually makes sense for you and your research and your situation and your team. So I recommend just taking small steps. And here are just a few ways that you can get started. So if you're involved in a lot of research projects, just pick one project and implement one of those new tactics that we talked about, or maybe not new, but one of those tactics that we talked about today, right? So maybe you could get the files a little more organized into appropriate folders, or you could just set up a simple README file for your project. You could choose just one aspect of a file naming convention, such as that standard date format, and apply it to your files for one project. You don't even have to commit to a full file naming convention, just one part, right? If you're going to be starting a new project soon, try planning out the folder names and putting that hierarchy together before getting started for your folders, right? So that could be one thing you could do. Another thing you could do is do a scan. Just figure out where all of your data files are and document everything in a README file or a set of README files if you have more than one project. You could review your current set of resources and tools to see if you can maybe automatically gather some of that metadata and documentation details without having to change your workflow at all, right? So that's one thing you could do. But in general, that idea of just weaving in recommended practices where you can, right? So that idea that practice leads to improvement, just try to do one new thing whenever you start a new project. That can just be a way to kind of start to build up some of that skill and some of that practice with managing your data. And then finally, one thing you could do is get an organization accountability buddy and just check in occasionally to see how you're doing on getting more organized. So this is useful because you can just set it up, set some small goals for yourself, and then you'll have someone that can help you reflect on how the small changes that you're doing or making are making a difference over time. So just having just someone to talk to about it could be useful. So once you're actively working on managing your data, or even just to help you identify where you could get started, it is useful to check yourself by asking these questions. So can you easily locate and understand the raw data that you're working with? Can you connect different types of related data that you've collected? So like if you've collected images and text, can you connect them together easily? If a file gets misplaced, can you put it back in the correct folder? Are your file naming conventions consistent with others on your team or others that you're working with? If another researcher were to ask you for a copy of your data 5 years after the close of your project, would you be able to easily find it and send it to them? Could all the members on your research team find it and send it to them? If a researcher were to receive a copy of your data, would they be able to use it without asking you too many questions? And that's related to like, have you been able to provide a good enough documentation? So these are just all great questions that can just help you see where there might be gaps in your organization or your management and just sort of help you see how well you're doing. Okay, so shifting into talk about data management plans. So if folks haven't heard of this before, what exactly is a data management plan or DMP, or sometimes it's also called a data management and sharing plan or data sharing plan? So basically, it's a document or a statement that outlines what you will do with your data during and after a research project. Importantly, it is a living document which should be updated throughout the life of a project to reflect the changing needs and circumstances that may affect your data. And I did have another poll because I'm just curious if if folks have written a data management plan in the past. So I just launched that. So go ahead and indicate if you've written a data management plan before. So you can choose yes, no, or I'm not sure. So it looks like we have a mix here. So some people have written one, some people haven't, and it looks like one person is not sure, and that's totally fine. Sometimes I feel like there's so many documents that you write for your research. I'm like, I don't know if I've written one of these.
Can I ask a quick question? I'll be honest, I
Yeah,
answered that I'm not sure. I know I've never
yeah,
written one for a grant because I haven't written an NIH grant
sure.
for a while since that it became a requirement. But when we write an IRB proposal, they say like, what are you going to do with the data? So I mean,
Yeah,
even if you've written 3 or 4 lines there and say, we're going to keep it confidential, we're going to store it here, etc. At some level,
yeah.
that's a very cursory data management plan. So
Yes, I would. Yes, I agree. I agree. I think it's kind of any sort of, like I said, a document or just a statement about kind of what you're planning to do with the data.
yeah.
That would count. Yep. Awesome. Thank you all for sharing in the poll. So I just wanted to cover briefly. So there's just a number of benefits to having a DMP. So as sort of we talked about, it may help you demonstrate compliance, right, for a funder or a publisher, or even at some institutions. We don't have a requirement here at U of M for a data management plan, but I know there's actually a handful of institutions where they require their researchers to write a data management plan for their projects. A data management plan can just overall help increase efficiency and reproducibility of the project because there's this guiding document to help all team members know about the project, providing context for the data, how the data will be managed and shared, things like that. It can also help reduce risks associated with data security, data loss, or even intellectual property by really trying to consider these risks and preparing for them up front. And then having one central plan that's crafted early on in your research timeline, so kind of during that planning phase, can really help the project leader and administrators to harmonize your thoughts and actions in regard to data management and sharing across the whole range of project-related documentations that can include things like your grant application, like your IRB application, providing a data availability statement to a publisher when you're going to publish an article, and possibly others, right? So that can just be really helpful document to just make sure you're being consistent with your plans across all these other sort of study documents. A data management plan can also increase a project impact by helping just prepare the data for sharing ahead of time and help carry out that act of sharing, because successfully sharing data can just help increase a project's impact overall in your field. And then finally, a good DMP can also serve as a reference for long after a project has wrapped up. A DMP allows researchers to be able to revisit your data as needed and then just better understand all the decisions that were made about the data. So here are some typical elements that you'll see in a data management plan. So a data management plan could include things like a description of your data types or overall description of your data, kind of how much data you might be generating. It'll include metadata, storage, backup, and security information, provisions for protections or privacy for human subjects data, policies for reuse, access and sharing information, timelines associated with managing and sharing the data, and then roles and plan oversight. And we're going to go into detail about each of these sections next. So data types or description. So this section of a DMP will and provide details about the data that will be collected or generated. So it usually includes details like the data source, formats, and the size or volume of the data. So the text in this section will usually be very specific to the project that you're writing it for, and it's unlikely that you'll be able to find any sort of boilerplate or template text that you can just kind of copy and paste. Excuse me. So in this example, I'm not going to read the whole thing, but basically what they are saying here is that they'll be producing clinical data, proteomics data, metabolomics data, and they indicate that the number of expected research subjects is 354, and they indicate that tabular data will be in CSV format. So it's just kind of a pretty thorough description of the data without going into like a ton of detail, right? Metadata is data about data. So this section of a DMP will be where you describe how you will document and describe your data. So this will be the details needed to make your data meaningful and useful for others. So it may involve using a metadata standard, or you might just indicate that you'll be sharing a data dictionary along with the data. You can also indicate if some of the metadata will be automatically generated, which could be the case if you're using a particular device to collect or produce the data. And it's possible that you could find some existing text to insert into this section if you're using a metadata standard. So just as an example, you can see here that they are sharing a data dictionary, but they also indicate that they'll be using a standard called the minimum information about a proteomics experiment. And they also indicate they'll be following guidelines from the Metabolomics Standards Initiative. So there's a couple different things that they're doing in this section, but it's all about that metadata that will help people kind of better understand the data that they're generating. Storage, backup, and security. So this is the section of the DMP where you'll describe details of how the data will be stored and secured during the project. Depending on your situation, you might be able to use boilerplate language from your institution or other storage solution. So in this example at the bottom of the slide, the data will be stored in Dropbox, and only research team members will have access to the files. This is a very concise example, and it would probably be sufficient for a funder-required data management plan. But if you're documenting more detailed information for your team, you would probably want more thorough and more detailed description of the storage locations and practices. And I see a comment, it seems like a lot of the information from the DMP could be used to write README files. Yes, that is true. You could kind of look at your DMP, and that can kind of guide how you're writing your README files. So it's worth noting that data storage is necessary both during your research process, which is often referred to as active storage, but then also once the research has been completed and no longer needs to be accessed much, that's usually referred to as that archival or preservation storage. So I've already mentioned the ITS Data Storage Finder, which can hopefully help you identify appropriate storage options. But for long-term preservation of completed works and data, you actually do have access to Deep Blue Documents for documents and Deep Blue Data for data at no cost to you since you are U of M researchers. They are repositories for all U of M affiliated researchers, and the Deep Blues are good for sharing data and documents as well as that preservation. And then there's a couple additional links on this slide that have additional resources and information about data storage, so I encourage you to check those out later. And then provisions for protection or privacy. So this section of a DMP really only applies if you're working with data from human subjects. So this is where you would indicate how the study participants are protected, or you would indicate that no protections are needed, right? So this section will include mentioning things like if you have an informed consent process, if you're de-identifying data prior to sharing, if you are going to be requiring a data use agreement for if people want to reuse your data, and possibly other protections such as like a certificate of confidentiality or others. You may be able to reuse language here from other sources since these types of provisions are often applicable across studies that work with human subjects data. So in this example, you can see that they're stating that identifiers will be removed, and they also note that there will be an informed consent process that study participants agree to sharing their data with the wider research community. And again, I'm going fairly quickly through these slides because I know we don't have a ton of time left. So I encourage you to come back and revisit the slides. I'll share the link again at the end. Another possible section of a DMP is about policies for reusing the data. So if there are any restrictions on how the data is reused, you would want to indicate that here in this kind of section. So some repositories, for example, they might require agreement with reuse policies before people can access the data. So for this section, you may be able to find some standard language that talks about a data use agreement, for example, or a repository might have some language that describes any reuse policies that we have. So this particular example, it might not be super helpful, but it is a legitimate way to sort of describe if there aren't any limitations or restrictions on data reuse. So this section, which is access and sharing, it will include information about where the data will be shared, such as on a data repository, or if it's available like upon request or something like that. If you're sharing upon request, you will need to indicate how people can submit a request for the data. But I also want to note that in most cases, these days, funders and publishers will often expect data to be shared in a repository. So that's just something to keep in mind. You would also indicate in this section if there's any requirements for accessing a repository or the data. So for example, a repository might require like an account to be set up in order to access or download the data. Or it's possible that in some places you have to have like an IRB approved proposal before you can access data. You can also indicate how the data will be findable, such as having a persistent identifier like a DOI or like a stable URL where folks can access the data. And again, if you're using a data repository to share the data, the repository that you're using might be able to provide some language that could be used for this part of a data management plan. So for example, like a brief description of their repository and the access processes. So in this example, you can see that it's using Deep Blue data. So the data will be shared in U of M's data repository, Deep Blue data, and they describe that access is free, that the data will receive a DOI after it's deposited. And Deep Blue data does have this language available, which you can actually access at this link here that I'm putting into the chat. And then the timelines part of the data management plan. So this is where you'd indicate both when and how long data will be available. Again, there might be some specific requirements about timing from a funder. So definitely keep that in mind before writing this section of your data management plan. So this example indicates that data will be made available as soon as possible, but they also note that the publication time is a timeline marker, is when it's going to be shared. And then the end of the award is the other kind of timeline marker. This example does not include an endpoint or a duration, but you definitely should be sure to include that kind of information in this section. And then roles and plan oversight. So this is just where you would indicate the people who will be involved in maintaining and carrying out this data management plan. So usually this would be the PI who's providing oversight, but there might be additional people involved with sort of data related roles, and you could write about those roles here. So in this example, you can see that the PI has oversight and will be revising the data management plan as needed. And again, I know I'm going through all of this very quickly, just a few more slides. I'm not going to cover this in detail. I encourage you to check it out. I just included information about the NIH data management and sharing policy here because that's just kind of one example of where you can see a data management plan sort of being required and sort of look at these details of what they actually want in their plan. So it is a little bit different than some of what I talked about. I tried to sort of cover data management plans generally, but you can see in this example the specific sections that they ask for in the NIH. So just going kind of back to generally about data management plans, there are some challenges associated with writing a DMP. So first, it can be really challenging to fully understand and describe your data before you've even really started the project, right? And related to that is just it can be hard to estimate the overall data volume and any associated costs, which are often asked for in a grant application. It's also challenging to make decisions about how you're going to be storing and sharing your data so early on in a project. And many researchers are just not aware of all the repository options that are available for sharing data. So it can take time and effort to really find the right repository if you're going to be sharing your data that way. And then again, it can also be a challenge to just kind of balance all of the data related requirements that you have from a variety of entities, right? So there's the IRB, the funder. If you're going to be publishing and you're aiming to publish in a specific journal, that journal might have data sharing requirements as well. And then finally, although a lot of planning and preparation go into a research project, things do not always go as planned, right? So it can really just be a challenge to maintain that plan throughout the duration of a project, whether things change with the data itself or the repository needs to be changed or, something else happens. So this is just kind of a number of challenges that you might encounter when writing a DMP. But before wrapping up, I just want to go over some general best practices that can kind of help with writing the best data management plan possible. So the first thing is to start early. So starting early if you can. Will just help make sure that you have the time that you need to reach out with any questions, make various decisions about your data, and find the right repository for your data. When writing a data management plan, it's best to be thorough. If you're writing for a funder, it's good to make it very clear that you're addressing all the required elements or sections. So rather than writing kind of one long chunk of text, make sections with those required elements. Use a formatting page if they've provided one or a template if they've provided one. And then just be sure to add some text to each section, even if it's just to indicate that it's not applicable for your project. But also make sure that you're putting information in the correct place. So for example, if the first section is asking for a data description or types of data, don't talk about the repository where you're going to be sharing it there, right? You want to put that down where they're actually asking for where you're going to be sharing or how people can access the data. And you want to try to avoid repeating information in different sections, since if you have to update the plan, you'll have to make sure that you update it in all the places that you mentioned that one thing, right? So keeping that information about what repository you're using to like just that one section where they're asking about the repository. The other thing you want to do is just provide enough detail about your data. So even if you're unable to be super specific about the data, describe them as best you can, right? The types of data, the volume or amounts, formats of the files, things like that. So make it clear that you are aware of what the data is that will be generated from your project, right? Like, again, trying to convey like, yes, I know what I'm doing. Here's the type of data that will be generated. Another thing, which I think I mentioned this a little bit, but if you can connect with your chosen repository ahead of time, if you're using one. And this can just be useful because then you can confirm that the repository is the right fit for your data, and they may be able to provide information that you can then include in your data management plan for describing the repository. And then finally, and this is particularly applicable for when you're writing for a funder, don't overcommit. So depending on what the funder requirements are, you might be including things like a timeline, right? So state your bare minimum that they're requiring for your timeline. Don't overpromise anything, right? And so if they want you to provide oversight on your plan, you can say, yes, I'm going to be providing some oversight with regular check-ins, but don't say that you're going to be doing monthly check-ins or something like that, right? So kind of meet their requirements, but don't overpromise. And then we do have some tools for writing a data management plan. Again, I'm not going to go over these in detail, but I did want to highlight that we have a couple teams on our, at least at U of M Ann Arbor's campus that you can reach out with any questions. I put information for those teams down there in the chat. And I'm guessing, Emily, folks are also welcome to reach out with you with questions. And if Emily doesn't know, she can reach out to us. We all work together to make sure you're getting your questions answered. And I also wanted to highlight that U of M is a participating institution with DMP Tool. So you should be able to sign in and use that resource to help you with writing your data management plan. And again, I'm not going to go over in details, but I will provide a link there and reach out with any questions that you have with that. And then I just wanted to highlight too that we actually, down at the Ann Arbor campus, we taught a couple workshops back in the summer of 2023 related to data management and sharing. So I encourage you to check those out. The content that I talked about today was present in the first two workshops that we did. And then I would say I did kind of an abbreviated version of both of those workshops, kind of crunched into one. So those two workshops do have a little more detail than what I talked about today, if you want to check those out. There's some additional resources, and that's it. Whew, made it. So we have like 1 minute for questions.
Thank you for watching this recorded webinar. Find upcoming webinars to register for at libcal.umflint.edu.